Hi, my name is Jim, and we're going to explore how to use a scientific calculator in the normal, scientific notation, and engineering modes. And I'm using a TI-83 here, and the mode settings on this are very similar to just about any scientific calculator. So turning it on, I want to first start with the mode settings, and at the top I have three settings here: normal, scientific, and engineering. And I'm going to set that on engineering or scientific notation rather, and hit enter. And the other mode you'll have to change frequently in AC circuits is radians to degrees, but obviously not going to discuss that now. So at present it's in scientific mode, and what I'll do is enter a 5-digit number here, say 52,894. If I hit enter, that'll convert this into scientific notation, and what my expectations are, it'll be a 5 followed by a decimal point, and it'll be raised to the 10 to the 4th power. And as we see, that's what we have here. Now let us go in the other direction a little bit. Let me enter another number here, say 0.00085, and now I'll put one more zero on it, I suppose. This might be, say, 850 microamperes, and if I wanted to express that in engineering notation, what I would expect to see would be an 8 followed by a decimal point times 10 to the negative 4, because I am moving the decimal point 4 places to the right. And hitting enter will do that conversion here, 8.5 times 10 raised to the negative 4. Now notice the notation here. E stands for times 10 raised to given the power. Now the trailing zero was eliminated from this because it's really not necessary. So if we go on with this and take a look now at engineering notation, and do note that I'm not doing anything here except changing notations. I'm not doing any real mathematics. We'll go back to mode, and then we'll go over and select engineering, and hit enter, and then I'll clear this. And now I'll take our 8.5 times 10 to the negative 4 and convert that into engineering notation. I'll just hit enter. And what we see is that comes out to be 850 times e to the negative 6. Now the important thing about this is that in engineering notation, the power that 10's raised to is always going to be divisible by 3, which means we can use our prefixes to represent this without using times 10 or exponent negative 6. For example, I might say that this is 850 microamperes. So the word micro means times 10 to the negative 6. And contrarily, if I have, say, 95 to 10, and I'm in engineering notation, and I hit that, is what I'm going to see is 95.21 E3. Now since that's a positive 3, what that means is kilo. So this might be 95.21 kilovolts, 1,000 volts, or 95.21 kiloohms. So again, we use the prefixes to eliminate the necessity for saying times 10 raised to some power. Now if we take a look at some real work, suppose that I want to find the power in a resistor here, and we'll say that the current flowing in it is 5.5 milliamperes, and the resistance is, say, 12 k ohms. I can enter that, and remember the milli is going to be times 10 to the negative 3rd. So I'm in engineering notation, not that that matters for this particular value, but that would enter as 5.5 second key. Then I have an EE here, which means enter exponent, and since milli is going to be times 10 to the negative 3rd, I would use my change of sign key. And let me just slide this here to show it real quickly. It's this guy right here, and it is much different than subtract. This is a unary operator. It just tells the sign. This is the binary operator. It sits between two numbers. So getting back into this again, 5.5, change the sign, 3. That would represent our current, 5.5 milliamperes. And the formula for power is power equals the current squared times the resistance. So I want to raise this to the second power. So here on my calculator I see an x squared, so I'm going to press that. We see the exponent 2 pop up behind the 3. And then I'm going to multiply that by my resistance, which whatever I said it was, we'll make it, I think I said 12K. Well, we'll use 12K times 12, and I could enter that as 12 times 10 to the third, but I'm not going to. And then hitting enter is what I see is my answer is 363 e to the negative third, so that means the power would be 363 milliwatts. Now, when we do calculations like this, instead of entering 5.5 e negative 3, second enter exponent negative 3, if I like, I can just enter 0.005, and that's going to be the same value. And then if I multiply that times our 12,000, this time I'll enter this as 12, enter exponent 3, will give us the same answer. Oh, I forgot to square that. Well, that's okay. What that turns out to be then would be voltage. It would be the current times the resistance is the voltage. So if I've had a 5 milliampere current flowing through 12 kiloohms, there would be 60 volts dropped across that resistor. So that mistake worked out okay. Now, what's the deal here? Well, in one case I entered this as 12E3, in the other case 12,000, and the answer is what's faster and more convenient for you to enter? That's what you should do. If there's more keystrokes to enter the exponent, and it's easier to enter it directly as 0.005, then do that. You know, it doesn't really matter. The calculator is going to keep track of the exponents. So by using the calculator in these modes here, what you can do is check your ability to transfer normal numbers, like what most people use, into scientific notation or into engineering notation, or back and forth between any of the three. So that's kind of the power of a scientific calculator, and obviously it becomes very helpful, very necessary to know what your prefixes are, because nobody's going to be talking about the resistance being 12E3 or 12 times 10 to the third power. It's very simply 12 kiloohms. So that'll do, and thank you for watching.